Hello, hi, it's 3 o'clock and we are here live with all of you back here again. Cool. Are we ready? Welcome, Branson, Chloe, Isra, Joshua, Kai Ching, Laya, Rahul, Usha, Will, Violet, Yar, Vernis. These are all the people that I've got today. Okay. We are here to do some water. What did we do last week? What did we do last week? Okay, you can always comment and I will be able to see your comment. Of course, I can't hear your voice because we have to keep as quiet as possible to make this lesson a smooth one. But all your comments are coming into me. So as we are learning, anything you want to say, just type it out. All right. Last week we did not do water and its cycle. We did. Yes, we did. Which part of the water? Yes, we did the exact same thing. So last week versus this week. Last week we did boiling point. No, just boiling. Boiling, opposite of boiling is something like that. Then we have melting, and opposite of melting is we have something like that. Okay, we did this. And then we had a big plus. We said we have something called VP. It's called boiling point, freezing point. Okay, and FP, freezing point, can also be melting point. Okay, and the opposite can be condensation point. Okay, all of them occur at the same temperature. For boiling point is for water is 100 degrees Celsius, only for water. All other liquids and substances, no. For water, what is a freezing or melting point? 0 degrees. Because the number is so nice, so exact, that's why we take water as the classic example to study all the relationships that they go through or what matter goes through. Of course, there are other liquids, other solids, other gases in the world, but we take water as the primary one because it's easy for us to understand and learn the other characteristics of the matter when they go through melting, boiling, freezing, and so on. Because water is available in our house, we drink it every day, we know it very well, they are like our best friends. So, and also the number is so perfect, 0 and 100 degrees. Okay. Okay, so we must have based this 0 and 100 degrees based on water. Okay, so today, what are we going to do? So I'm going to be here today. Today we're going to do, I think those of you who have done the homework, you probably know we're going to bring across this other process called evaporation, which we did not cover at all last week. We did boiling, we did melting, freezing, condensation, 4 important steps. But one more process is called evaporation. I'm going to do that today. Okay, what else? We're going to do the water cycle. Once we know what is evaporation, then we can move on to the water cycle. So how many processes do we know altogether? Okay, number 1, freezing, melting. 2, number 3, condensation, boiling. Now today will be the 5th one, which is evaporation. Now this is interesting because evaporation and boiling is very similar, so students tend to get confused. So we need to pair them up together, pair these two together, and be like, hey, both of them involve the state change of liquid to gas. Same. The others all have their own unique change. Why? Freezing is liquid to solid, melting is solid to liquid, condensation is gas to liquid, but the last two have the same change, liquid to gas. Okay, so this is very similar to last week we did. Okay, what do we do? We found out, remember, the difference between, who remembers this part? The difference between steam and if you know the difference between these, then today's lesson will be much easier because we can know what's the difference between boiling and evaporation. When something boils, say water boils, it becomes 100 degrees Celsius. So steam is at 100 degrees Celsius. This is a cause because water has boiled, or water is boiling. Whereas vapor can be in the air at any time. Now, I'm in this room. Do you see any water that I'm boiling? I'm not even in the kitchen, but there is water vapor in the room. Why? Because I am breathing. Okay, there's air coming out of my body. That is the air that comes up and okay, you guys have read already. I give you a bit more than 15 seconds. Actually, my Zoom went out somewhere, zoomed to the water vapor and came back. Okay, somehow. So let's read the 5 points that we need to be very aware of in order to understand evaporation versus boiling. Evaporation occurs only on the surface of the liquid, whereas boiling occurs at the entire length of the liquid. What does that mean? When I draw something, there's 2 differences here. Okay, now I just shade for you. This versus this. Which one is evaporation? Ta-da! Which one is boiling? Ta-da! Okay, that's the classic drawing for explaining point number 1. So the particles only at the top will go up. Here also the top only will go up, but they come from bottom as well. That means, let's see. That means they can come from here, which will rise and then reach to the top. Am I right? Those of you who understand boiling very well, you know. But this one, only particles from here can escape. Okay, so that's the difference. Okay, number 2, boiling occurs rapidly, whereas evaporation occurs slowly. Oh, okay. Let's highlight that. That's why you don't go near boiling water, right? It looks very dangerous. Just boiling, a lot of bubbles. Okay, so that's why we can go straight to number 5. There's a formation of bubbles, whereas evaporation, you don't see the bubbles. It's so slow and so calm, as though it's in meditation. Okay, evaporation is in meditation like that. So calm, but still water vapor is coming out. Use the right terms. Here, water vapor or steam. Okay, the right name. They may look the same, but we name them differently so that all of us know what is exactly happening. What's the process? Okay. Okay, how many more points do we have? 2 more. Evaporation occurs at any temperature, whereas boiling occurs at a specific temperature. What does that mean? Okay. You guys have listened to me, but you didn't see the screen, right? Okay. No problem. We are still on the same slide. Okay. Okay. So whatever I've written now, can you all see? Can or cannot? Can, right? Okay, good. Okay, so we covered the first point is to look at the diagram here. Okay, can you see the diagram on the right where I wrote E and B? Okay, evaporation occurs only on the surface versus evaporation occurs throughout the liquid, boiling. Okay, so you have particles that can come, the yellow particles from boiling can come all the way out of the liquid. But for evaporation, you only have on the surface. Number 2, boiling occurs rapidly versus evaporation slowly. And then I went to number 5. there's a formation of bubbles because it's occurring rapidly. You can see the bubbles, and also you call it steam that is escaping, whereas in water evaporation you call it water vapor. And I mentioned this word meditation. Okay. Versus exercising, vigorous exercise versus meditation. So slow versus fast, and bubbles versus no bubbles. Number 3, evaporation occurs at any temperature, whereas boiling occurs at a specific temperature. Okay, evaporation occurs at any temperature, whereas boiling occurs. So what's the specific temperature for water? Here we did not say water, but this is for all liquids. So water specific temperature is, you should know by now. Okay, whereas for any temperature is any temperature. Okay. Number 4, motion of particle is fast, again, versus evaporation, few particles move slowly, again same thing, and few at a faster rate. Why? Because of this, few are fast and few are slow. Okay, because the highlighted part are the only ones that are fast, the one that is shaded on top. Whereas in boiling, everywhere is fast moving. Okay, basically the action of evaporation is taking energetic particles away from the surface, so that means they are very fast. Fast means high energy. All right. Okay, next slide. Factors affecting rate of evaporation. What does that mean? Okay, another 10 seconds to read it before I go through. Okay, that means you already done this a lot in classroom, I know, because your teachers are actually stressing on this one, right? Because in the questions, they always talk about these 4 factors that affect evaporation. And they keep testing you. It could be in the open-ended or in the multiple choice questions. You have to know these 4, okay? This is an experiment where you place water just lying somewhere on your table in the room somewhere. Okay, I know some of you also have some home-based learning to do this experiment in your SLS to do rate of evaporation test, and you just leave water. So let's have water as blue color, and just leave water, and to see how long it takes for it to become less water. So what happens is the water level drops, right? So same container, but the water level drop by very little. This is not boiling, this is evaporation. It's very slow. You need to be patient. It can take hours to see, because some of you did the experiment. How many of you did the experiment at home before or in school? You can raise your hand up or just tell me with a thumbs up. Okay, then I can see you guys have actually done it. Why it takes very long? Because it depends on the 4 factors that are listed on this slide. What are the 4 factors? It depends on the temperature. Is your room hot enough? Okay, maybe you're doing it in your room where it's so cold, it's air conditioned, so the process will be slow. You cannot give the particles. The particles are all here. You know? What do you need to give the particles? In order to escape. In order to escape, you need to give the particles some energy. The energy come from where? The room, your environment. So just keep focusing on what I'm writing, then you will understand. Okay, the energy comes from the environment, which means, is your environment cold or hot? If it's very cold, then the energy that you provide the water particles is not enough. Maybe you bring it out to the sun, it's very hot. Then maybe. You bring it out to the sun, you don't call it boiling yet, right? You still call it evaporation, because it's not moving to 100 degrees Celsius. Your environment outside in the temperature, where it's hot and there's a sun, is probably what, 30 degrees? Is this boiling? No, it's only 30 degrees, not 100 degrees. So you still evaporation. Don't worry, don't say evaporation is in the house, and when you bring it out to the sun, it's not fair. Okay, it is fair, but you're increasing the temperature of the environment. So that's point number one. So let's circle point number one. Done. Okay, temperature will affect how fast the evaporation occurs. I think I'm very proud of my diagram here on the bottom. So it can clearly explain what we are going to go through as experiment. Okay, next, surface area, number 2. Also I've drawn the two different surface areas. One container has a large surface area. Open up the top, giving what? How many particles do I have on this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 little circles. Here, if I draw the same size, 1, 2, 3, 4, 5, 6. Can you see the difference? Yes. Why? The surface area is much lesser on that. So even if you give the energy, let's give the energy here. See my arrow? Now, even if this energy goes, only 6 guys can go up. The other one, 9 guys can go up. So doesn't it affect the rate? More water vapor can go up quickly, whereas for the smaller surface area, only less water vapor can go up. So that's why point number 2, circle already, surface area. Okay? Humidity. Aha, what is that? Now, many of us struggle with this factor, humidity. What is it? It means how much water vapor is already in the air. Okay. Now, Singapore is known to be a very humid country because it's very humid. That means there's a lot of water vapor in the air already. That means there's always evaporation happening from all over, from your reservoir, from your sea, from your river, from your drains. The water is rising because we are in a hot country. All the time hot. There's no winter. Okay, and so on. So it's all the time hot. So obviously more energy is being given to our water bodies around us. So there's more and more water in the air. A lot of evaporation happening in Singapore. So therefore, humidity is the amount of water vapor present in the air. I'm circling it right now. You can see amount of water vapor present in the air. Okay, so what happens is, I'm going to choose a new color for humidity. Let's choose green. So there's humidity. Look at this. See where I'm going to draw. See how many of you can see where I'm going to. Look at that. There is humidity. A lot of water vapor in the air already. So what happens with this green is up there? Is blocking. Is blocking the particles from rising up. Remember, the yellow guys are trying to go up, but the green guys are already there. It's full house. They say, but sorry, I'm already here. No space for you. So the evaporation actually drops. Evaporation cannot occur because it's humid. The humidity level is high. What is humidity level? The green particles. All of them are blocking. Okay, so we look at number 4. Wind speed. Evaporation increases with the increase in wind speed. Yay! Now I'm so happy because I can bring in my. Okay, let's bring in my orange color. Wind. Ta-da! Let the wind come in. This is wind. Wind is very powerful. What can the wind do to the green color guys? Okay, look at it. Ta-da! What happened? What happened? Ta-da! It's pushing these humid guys away. So there's more wind. So there will be less humidity. When there's less humidity, the yellow guys are happy again. They say, thank you for the wind. Now we can escape again. Yay! So evaporation will increase. So wind speed is also important. You always have to keep the surface clear of any humidity that is blocking its process of rising. That's all. This slide explains everything in the terms of the diagram below. All good, right? Okay, I hope the diagram really helped you. I'm also, like I said, I'm really happy with the diagram today. Okay, let's move on to something exciting. Quiz. Okay, I actually flashed this quiz to the participants today. Okay, and what happened was we received a couple of answers in my WhatsApp. Okay, and not all the answers were perfect. It's good, okay, because I have not covered the topic before giving you the quiz. I gave you a quiz so that you can prepare yourself for today's lesson. So today's lesson is going to help you to answer this quiz question. So those of you who actually managed to do some research on your own and answer it, which means that means you're ahead of us. You already know what I'm going to talk about, what we're talking about in today's lesson. Those of you who didn't even try, then you are a bit lagging behind, you're a bit slow because you haven't actually attempted this question. Now let's attempt this question from last week, and then let's see if anyone won this quiz, because I was about to give them some prize, which I'm not going to reveal until someone wins it. So let's see if someone won it in the next slide, okay? Will the temperature of water affect the rate of evaporation? It's a very important question. Yes or no? I want answers. Yes, yes, yes or no. Temperature of water versus, what did we study in the previous slide? Is it temperature of the water or temperature of the environment? Which some of us also call it surrounding. Now, this is the important part. You're confusing yourself. Temperature affects, but temperature of environment, the surrounding, that means if I'm in the aircon room or in the outside in the hot sun, versus the temperature of water itself. Remember, okay, let's do this. I have two beakers. Put the water in. 1, 2, 3, 1, 2, 3, or everything exactly the same, but the temperature, okay, outside is 30 degrees Celsius because they are outside in the same, on the same place. But I'm going to change the temperature of the water. Temperature of water is cool, 20 degrees. This one, 35 degrees. You see, this is what they're asking. So you see, you guys are changing the answer now. Is it yes or no? The question is, will the temperature of the water affect the rate of evaporation? Will this have more? Will this have more like this? Which one? I'm going to erase because that's not the answer. That's just a question. You did not send me the quiz. The quiz was actually from the end of last week's lesson. I said take a photo, remember? I said take a photo. Never mind, we still have another quiz this week. Okay, at the end of today's lesson. Look out for it. Don't forget, I'll tell you. Okay, so this one, what happened? Here, so let's go through. Now, we do not know the answer. Let's say we do not know the answer. That's why this quiz was there. Let's look at part 2. How will you design an experiment to find out? What variables do you have to keep constant? What must you do to make sure your results are valid? Now, this is the, so now part 2 is, can we conduct an experiment to find out? So 2 beakers may not be enough. So let's try 3 beakers. Let's conduct an experiment. Everything must be the same. Amount of water must be the same. The beaker must be the same. The beaker's surface must be the same. The surface area must be the same. Except what must change? Water temperature. Yes, because that's the aim of the experiment. So that we can test whether this water temperature affects or not. So what temperature can we give this? One is lower, one is more. Maybe this one we can give 30 degrees, and this one maybe, how about 40? Does it make sense? Because our sun is shining us at 30 degrees. So we keep one at 30 degrees. We keep one at lower 20 degrees and keep one at 40 degrees. Now, do we keep them there forever? So this is what you will do and tell me, how will you design the experiment? I will have 3 beakers having the same amount of water, the same type of beaker, the same surface area, the same place where I will place them, location, surface area, everything else. And then also the time that I will be testing. I can't say, oh, for this one, I will check after 5 minutes. The other one, I'll check after 1 hour. The other one, I'll check after 2 hours. No. All of them, you check after the same time. So how long do you think will take up? 5 minutes? Do you think you need to go back and check after 1 hour? After 2 hours? 3 hours? Roughly, tell me on your check, tell me. How many hours would you take to go and test how much water has dropped? Okay, how do you measure? How do you measure? Measure by the amount of water left, right? Amount of water left. If less water is left, then of course more evaporation took place, because initially all of them had the same amount of water. So prepare a few setups with everything except the temperature. 1 to 2 hours. 1 to 2 hours. Okay, roughly about 90 minutes, which is 1.5 hours for 2 hours. I think to be safe, just take 2 hours, because after 2 hours, you are saying, oh, okay, this is a standard. My time will not change. I'll check after 2 hours. If 2 hours you still don't change, then maybe 3 hours. Every hour you take a amount. So maybe actually you should do this. After 1 hour, how much water was left in ml, right? After 2 hours, how much water was left? After 3 hours, then maybe you can have a check on that. And then you have to label them A, B, C. And then you do a table up and then find out which one reduced by the most. And that one evaporated the most. Okay, so now, finally, how do you make sure your results are valid? Redo the experiment one more time on another day maybe, okay? Because on the same day, because the environment maybe on that day maybe a lot of wind. So because of a lot of wind, there might be a difference in the results. So you must do another day to see an average of the two results, okay? So we do not want to have any other external factors change, because during the 1 or 2 hours, sometimes the wind may stop and then the wind may be increased again. So we don't know. So if you do it a repeat again, that's where you can make sure your results are valid. The more you repeat, the better. At least 3 times, if you can, if not 2 times. But 1 time, not accepted. Okay, so this is the answers that I was expecting from you. So let's look at this. Project design plan, see, Mr. Ali, he sets up his answer. This is what I would have sent my teacher if my teacher gave me a quiz. Problem statement. The purpose of this experiment was to compare the effect of temperature on the evaporation rate of water. The goal was to establish 3 containers of water. Each container contains the same amount of water. Surrounding air and humidity are kept consistent. One air is kept at a consistent room temperature. One container is kept at a heated consistent temperature. And one container is kept at a cool consistent temperature. Remember the cool consistent. Okay, so the temperature must be kept consistent. You should not move it anywhere. So the location must be the same. The experiment will show how 3 different water temperatures affects the rate at which the water evaporates from the container. This is my design. And then there's another question that asks, what are the factors that I need to keep constant? The type of water, the amount of water, the location, the size of container, the number of tests conducted, the type of container, okay, and the length of the time that water has to evaporate. Remember, we went through all of this. Okay, so who won? Mr. Ali lah, me, because mine is the best answer, right? Okay, I had 6 people, but all of them couldn't give me some of the factors that I was looking for. Okay, especially some people didn't tell me this, the amount of humidity. Okay, the humidity will be based on the location. Okay, so you can either write the location or the humidity, and I need to have all these constant experiment and a proper write-up of the design. And then at the end, you also have to give me a table of how your results were tabulated. Okay, A, B, C. This is the beaker ABC. After 1 hour, after 2 hours, after 3 hours. 10, 10, okay? Or at the start. Start. Of course, start, you know, all of them had 100 ml of water. Then 89, 90, 95, then 85, 88, then 92. You must, this is in ml. Okay, so roughly you know how you need to tabulate. Then after that, how do you get the answer? Okay, let's say 80, this one 80, this one 85, this one still wow, 89. So which one had the most amount of water left? C. Which one evaporated the most? Evaporated most. Then you check A. What is the temperature of it? So you need to check your table temperature. Oh, this one was 40 degrees. This one was 30 degrees. No, this one was 30 degrees, remember? This one is 20 degrees. What does it show? That the temperature of water actually affects, because remember, evaporation occurs based on this part. And the particles are over here, waiting to go up. So when it is at 40 degrees, they have more energy than the one at 20 degrees. If they have 20 degrees, they have less energy. And evaporation is purely based on the amount of energy you have. You have more energy, you can run faster. So it's like in your class, who has the most energy, you can run fastest during your PE lesson. Same here. The one who has more energy is the one with the highest temperature. You are very heated up. So you can go and test your friend. Those who are very hot are probably going to run faster because they got more energy. Similar, okay? Very similar to this kind of thinking, where the temperature will determine how much energy they have. All right? Okay. Anyway, yeah, so I have to tell that the answer wasn't perfect. Okay, so I can't really give the prize even if that person was the best out of everybody, but I'm looking for some other things. So for next week, definitely we will have an easier question so that somebody can win the prize. Okay, so let's have a look at what we're going to have at the end of the lesson. Okay, how many of you tried the questions? I'm going straight into the questions. I have half an hour and I have, I think, 11 MCQs. I didn't give you structure because MCQs are enough to kill us. Okay, so let's do more MCQs because we can actually work out a lot of concepts, because we can say why B is not the answer, why C is not the answer, and we finally arrive at, oh, A is the answer. We actually learn a lot more. Remember last week I told you, MCQs are more difficult than structure. Okay. So you are eager to find out the answers, right? How many of you got everything correct? That is, if you know evaporation and boiling very well. Half of these questions are to do with evaporation and boiling. Half of them are to do with the water cycle. Okay. So before the water cycle question, I want to show you a video. So wait up for that. Okay, let's do evaporation and boiling and condensation and all that now. Which of the following pair of setups do Kelly use to ensure a fair test? This is very similar to the quiz that I gave you. Okay. Kelly wanted to find out how the rate of evaporation, yes, as usual, we're always testing this, was affected by the temperature. Hey, isn't this what we just did? Very nice. Very nice that the question is the same thing. So so what is this? Dependent factor versus the independent factor. Dependent is the rate of evaporation. You check, you measure. You measure by measuring amount of water. It's always important to write this dependent, independent. Then independent is which one? Temperature, because that's why you're going to change temperature of water. So this one you must change. From last week, I've been doing this again and again. For any fair test, always write down independent, dependent. The independent will be the one that you change. You change the temperature. Remember, we changed 20, 30, 40. Similarly, she's going to change the temperature from she's only going to get two sets, 40 and 60. So we are going to see which are the two that she should pick. Okay. So temperature of water she should change. So that's why you cannot say P and R. If P and R are chosen, they are not changing the temperature. But you can choose P and Q. You can choose R and S, and so on and so forth. Okay. If you choose this, you can also choose one more. You can choose this 40 and this 60. Am I right? So these are the pairs and they are all in the answers options A, B, C, D. How to determine? The rest of them must be kept the same. Okay. So in two experiments, you need to keep them the same. So volume of water, all of them she kept same. Very good. So it doesn't really matter. But exposed surface area of water, she has 100, 100, 200, 200. So it's either you choose this pair or this pair. You cannot have 100 and 200, so you cannot cross over. Temperature of room, she chose 28, 28, 28. They must be the same, right? There's one that is 20, so that's one I want to totally cannot, because they are not the same with any. There's no 20, 20, so there's no pairing. So I can't use that as a pair, because here we're going to have a pair. So since 20 doesn't have a pair, I'll show you again, this 20 doesn't have a pair. So obviously this will not be part of the selection. Next, so therefore this 100 also goes away, right? This 20 goes away, and therefore she cannot go 100, 100. She has to go 200, 200. So that's why R and S looks like the best because they are 200, 200, 200, 200, 28, 28, and 40, 60. Yay. So these two will fit the pair of setup Kelly should use. So that was the answer, R and S. C. This one also very common based on surface area. Whenever you see clothes folded, spread out, this is smaller surface area, slightly bigger surface area, more surface area. Therefore, more surface area will allow more evaporation. That means water will leave, therefore more drying, therefore it will dry faster, right? Okay, that's all. So what's the question here? Which of the following will affect the rate of evaporation of each of the above tower? Presence of wind. Okay, this one is, we already know. It will affect. Exposed surface area, yes, it will affect. Temperature of surrounding, yes, it will affect. Length of plastic string which the towel are hung. That means this one, the length, no. Whether you make it higher or lower, it still have the same humidity, same temperature, same exposed area. So only the first three will affect the rate of evaporation. So you need to be very, very clear about the factors that affect, which we already discussed in one of the slides just now. Some of you said you actually did this question in the school already. Very, very common as well. All the questions here are common, comes out in PSLE. So please take note. If you have going through with me, that means you guys are, the 20 of you here today are actually more blessed than the rest of Singapore because you are going through PSLE question with me. Yay. And you will not get these questions wrong when they come out because you exactly know how to answer them and you understand them fully. So no need to read everything. They just evaporating some seawater to get some clean water to drink. They are at a camp. So somebody said it's a very clever method to get some pure water to drink, especially if you run out of water. Okay, take the seawater, boil it. It's easy to do fire also. Huh? You need to get some sticks that are dry, rub them together as hard as you can, and try to cause a fire. Not easy. Campers know this very well. Okay, you need to get some fire going, and you need to have some containers. I don't know if you brought a kettle, but it's good idea to bring a kettle along for a camping session. And the water you brought is finished. Of course, how many mineral bottles can you carry with you? Okay, once it's finished, and maybe 7-Eleven is closed, and all the shops are closed because it's COVID-19. And then what are you doing outside camping? You shouldn't even be out there. Okay. Okay, so all the shops are closed. Maybe it's past midnight and you need water. Okay, so you need to boil and get some water. So this is a process that will allow the boiling to take place. Okay, steam will come across here, and the steam will condense on a cold metal sheet. The metal sheet is colder than the steam because steam is at 100 degrees Celsius. Whereas the metal sheet is less than 100, maybe, usually it's cold, maybe 30 degrees Celsius or room temperature, okay? Usually it's cold or even colder, 20 degrees Celsius, depends. Because it's cold, once the steam touches a cold surface, what will happen? Condense. So the liquid will start forming and it will, of course, you need to collect it. So this is a clever way of collecting it, and your water is now free of salt. Because when you boil, the salt remains in the kettle. Because only water boils at 100, salt still remains. Now, what can we say for this experiment? Which of the following reasons are most likely possible? Why? After some time, the number of droplets formed on the metal sheet decrease. Then Fundi's friends were like, oh, no more water left. Hey, Fundi, earlier you had so much water coming. Now there's less and less water. Why? Why do you think there's less and less water condensing? Now, in order to condense, there must be a cold surface. Okay, more will condense if the metal sheet is colder. You see here, 20 degrees, 30 degrees, 40 degrees. So more will condense if the temperature is colder. Now the temperature is not colder, so less and less will condense, and less will condense at 40. How come it's becoming more warmer? the metal sheet? Because it's receiving some what? Heat from the steam. Remember, heat is being passed from here. So initially it may be 20, but over time it may be gaining some heat. So the temperature of the metal sheet increase is one of the possible reasons why less and less condensation takes place. The second is, of course, they're talking about A. This cover, where I'm circling, the cover here of the kettle was removed. If you remove it, what happens? All the vapor tries to escape this way because the area to escape is much bigger. Of course, some will come through this way as well, but it will be less and less. So therefore, the cover of the kettle removed will also cause the water to condense less because less steam is coming out this way. There are two channels now. So more channel to the left, some channel to the right. So therefore, you don't have the full channel on the right only. So you should keep it closed. But since it was open, less and less. Okay, finally B. The seawater had reached boiling point. Is that the reason why it decreased? But only when it starts to boil, you can get this condensation. So whether it's only at the boiling point, it did not reach boiling point after some time and then. Only when it reach boiling point. If it reach boiling point, you should get more and more condensation because more steam is coming, right? So this is not a reason why it's become less. Answer is A and C. All right. 4 similar cups were filled with 50 ml of water, all the same amount of water, different temperature. Oh, different. Take note of that. Always keyword. Placed in the same room at 30 degrees as shown. Oh, this is very similar to the quiz again. Water at 60, water at 20, water at 10, water at 30. Which cup? But this one is not about evaporation upwards. It's not. Some of you may think which one. Oh, the question is about water droplets forming. Okay, that means it's about this one. Remember, if you go to a food center, you buy a cold drink and sit down, and while you're eating your chicken rice, you will see water droplets on the cup outside. Why? Because the drink inside is cold and the air outside is warm. So this warm air will condense once it feels the cold areas. Remember the metal just now where the Fandi had at the sea, at the beach? It touched the cold surface and it condensed. Here also, which is the cold surface? Your cold drink. Your cold drink is cold. So once it near the cold drink, not very far away from the cold drink, must be at the surface because that's where it's the coldest. It will all condense. You need to have a surface also. So it will all condense. So will it condense here? Will it condense here? Which one will it condense? Wherever it is colder than the outside temperature. Outside temperature is 30. Okay. So if you go into an aircon room, your temperature is 24 and your drink is also 24, there will not be any condensation. Condensation will only occur when there's a temperature difference and the temperature, and then there's a heat exchange and there's a condensation. So here you can see X and Y are colder drinks than the external environment. Therefore, only X and Y will see condensation. You can try this. Okay, you can try this. You need to know what's the temperature of the room. Some of you have thermometers in your rooms. Some of you can bring a thermometer in the room and find out what's the temperature of your room. If it's 30 degrees, then you keep a cup of the same temperature and you keep another cup that is cold. Just take it out from the fridge. You will see that one will have the condensation, one won't have. Reason is the temperature difference. Is there a temperature difference? If the temperature difference, then the warm difference. Warm air will condense after it meets a cold surface, similar to the previous question. So answer is X and Y only. Am I right? Okay. 3 different containers A, B, and C, different sizes are used to find how the exposed surface area. Now, you see the volume of water is, let's say 100 ml. I'm just giving an example number. It's good in your question, you always give an example number so that you know what's happening. So at the end, container A had the least. Container B had 50, Container C had 80. Can you see roughly I'm giving a number? So container A had the least amount of water, least water left. So most evaporation occurred here. If most evaporation occurred here, then the exposed area must have been larger. This one, the exposed area must be like this. This one must be like this. That's all. So exposed surface area must be the largest for A, second largest for B, smallest for C in its order. Am I right? So that's how I check it out. This one 80 square centimeters, this one 50 square centimeters, this one 25 square centimeters. That's the only answer that is in this order. All others are jumbled up, so cannot be the answer. Easy. Diagram below shows the water cycle. So I need to show you the water cycle video. Okay, let me see if I can go to the video. Oopsie, where's my... Okay, let's see. Share. Let me know if you cannot hear the sound. Can you see a new video now? Hi. Is it raining at your place? It's really heavy here. Okay. I think that was also a reason why the internet was a bit slow, because you started a big video and then it started lagging a little bit. Okay, it's all right. You can find that video on YouTube anytime. Just type water cycle. You can find the video and watch it again. Okay, it's raining very, very heavily over here. Some of you are actually are also giving me comments that it's raining over at your place too. Okay, take in your clothes. Okay, and it seems like that's what we are going to talk about, the water cycle. Okay, about rain. And we heard this Dr. Binox. His name is Dr. Binox. You can see a lot of videos on science topics related to your PSLE Primary 5 levels to actually get a better understanding. So I actually show a lot of my students these videos to get them excited as well as to learn a lot. You can go and search for it on YouTube and basically search for every topic that you want to know. Electricity, magnets, living things, all of it are there. Okay. So, and also on my website, you can find the videos where I put them up. Okay, so let's quickly do the water cycle. This part is so easy compared to the first 5 questions, okay? Because it always talks about the process and the name of the product. Okay, process is the arrow usually. The product is in the box usually. Okay, so these two, if you know them very well, they can answer all the questions, which is essentially the essence of the next few questions. Very fast we can do. The diagram below shows water cycle. Which one of the following option is correct? You need to know the water cycle very well. Okay, answer. Some of you already share with me the answer on the chat. Yes, very fast. Okay, water vapor, process X. Water vapor becoming what? Oh, before it goes to rain. Water vapor will do what before it becomes rain? Cloud. Okay, before it becomes rain, right? So therefore B is cloud. And from water vapor to become cloud, this is the important part. Is it condensation or evaporation? Remember, water vapor is a gas. Am I right? So always write this down if you are confused. Here, cloud is tiny droplets. Hey, droplet means water. Liquid, you know, liquid. So therefore you know the process X is condensation. Okay, this is the important part. A lot of you make a mistake here because you could have chosen D instead of C. So answer is, am I right? Yeah. Answer is C. Am I right? It's condensation. Process from water vapor, gas to tiny droplets of water is condensation. So that's why you made a mistake. So a lot of you are not sure of the process. Whereas the product, you are very good. So first find the product, then Find out whether is it gas to liquid or liquid to gas and so on. Then you will find the answer. Okay. The water cycle undergoes a few processes that involve heat gain or heat loss. Which one of the following is true about the water cycle? Okay. Again, I want to highlight this part only because many of you make mistake here only. The rest usually is okay. Okay, so water to water vapor is, see what I do, liquid to gas, gas to liquid. Yeah, because this is tiny, again, liquid to liquid, liquid to liquid, how come? So that means there's no change in the state. So there cannot be any process called evaporation or condensation. Is wrong. Okay, what is this process from cloud to rain called? It's another process. It's called, some of you already know this word. You'll come across it in science textbook. Precipitation is the process where the cloud releases its water to become rain, and therefore the change is liquid to liquid, no change in gas. So this is a new process. Does not involve evaporation, condensation, boiling, or freezing. Okay, those other four will have a change in state. So this is something you learn. So let's highlight that and make sure you remember this. Okay, so which is the answer then? If C and D is not the answer, go back to A and B. Liquid to gas should be called evaporation. Gas to liquid should be called condensation. Both process names are correct. A, this one is okay, all correct. So that means the deciding factor will come from here. So since it's liquid to gas, it should be a heat gain. This is wrong. Here, gas to liquid is heat loss. This is correct. Understand? Thunder is killing my ear, says Laya. Yes, it's killing all our ears. Thunder, and it was raining like this, I think, yesterday too, right? It was very, very heavy. Don't know what's wrong. I think it's coming down to kill all the COVID-19 virus, which is very good, okay? Virus cannot survive in water and soap, right? So if it's in the air, you'll all die. B is the answer. The diagram shows water cycle. Which of the following letters A, B, C, D represent a change in state? Hey, must change from any state, maybe liquid to gas or gas to liquid or something like that. Okay. So which one represents a change? Remember, cloud to rain. Okay, I changed to red color. We just learned a name for B. We straight away apply precipitation. Where here the two states are liquid and liquid, no change. So definitely B is not the answer. So I go to my MCQ, I just do this. It helps me, right? Helps me. So it must be the rest. A and B. A, water vapor. This is from gas to liquid. Yes, A is correct. What about D? Sea water to water vapor. This is liquid to gas. Yes, D is correct. What about C? Rain to seawater. This one also liquid, this one also liquid. So all liquid, right? Can you see this side? All three are liquid. So C is also not right. So therefore, only A and D are right. Okay. So we see by LGS. As only write the whole thing down. Okay. Whoa. Big diagrams. Which of the following diagram correctly shows the water cycle and the process involved? We did this 4 times already. Since question 6, question 7, question 8. Now this is question 9. By now you should know, right? Let's see. But however, they throw in one silly boy here. It's called breathing. Animals and plants will breathe water vapor. Remember, at the start of this lesson, I said in this room where I'm sitting down, there is water vapor, even though I'm not boiling water, because I'm breathing. The vapor that I come out is coming out of my mouth is water vapor. So that's why this is correct. Water vapor coming to clouds. Is it condensation? This is gas to liquid. Yes, this is correct too. Water bodies to evaporation. This word is wrong also. So that's why these two are wrong, right? Okay, so I'm going to D straight away. Breathing, correct. Clouds to water bodies, liquid to liquid, okay. This one is gas. Okay, gas to liquid, this one, correct. This one, okay. Why? Because it's liquid to liquid. So there is no evaporation. This is precipitation. If you want to write down precipitation. So you keep learning the word precipitation so that you know it's not evaporation, it's not boiling, it's not breathing, it's not condensation, it's precipitation. If you know it is precipitation, then you will make it like, hey, how come it's evaporation here? So it's wrong. So D is wrong, A is correct. Answer is A. Okay, let's just check that again. Everything is correct, right? Unless I got it wrong. Okay. Now, water diagram below shows the water cycle. We got only 2 more questions, okay? Hang in there. What do letters P, Q, and R in the boxes stand for? Hey, come on. Now I don't need to do. I can just relax. You guys do it. Tell me the answer. I've done this 4 or 5 times now. Very easy. Same thing over and over again. Right? Okay, what is it? Okay, what is it? Rain, clouds, water vapor. Answer. I don't even have to go through. I'm going to give you the answer straight away. Number 10 is B. Let's skip this. You guys are experts and I'm an expert also. Finally, number 11. Okay, which of the following is not a way of conserving water? Just think about it. Brushing your teeth and using your mouth, rinsing your mouth with a mug. Oh, a little bit of spelling mistake here. Rinsing with a mug. Why do you use a mug instead of letting the tap run? If you let the tap run, what will happen? You turn on the tap and a lot of water, too much water wasted. So use a mug instead. You can keep the good way. It's a way of conserve water. Take a short shower instead of a long bath. Depends on how big your bath is and how much water you fill it up with. Imagine you see your bath. Is this water maybe 1 liter is 1000 ml? So maybe 10 liters. Okay, maybe even 20 liters sometimes. How do I know how many liters? In my mind, I'm going through, oh, I have a water bottle at home. 1 liter bottle is this much, you know, the mineral water. So 10 liters, no, not enough to bath. 20 liters, maybe still not enough. 30 liters, you see how much water you need to fill up a bath. But probably a shower, maybe next time you can stand under a shower. Now, you might use up about 10 liters or 20 liters. Shower short. If you take a long shower, then it's different. Long shower may be the same as long bath. So in the end, you are not saving anything. So this one would conserve water. Collecting rainwater. What about the other two? Collecting rainwater to wash the corridor. Good. You are saving water because instead of using the tap water from you, that water is actually clean because even though you are in the bathroom showering, do you know that water is good enough to drink? So we are using good drinking water to actually shower, which of course, I'm sure you can even shower in rainwater if you want. Shower in rainwater for a while, then shower. You don't mind having soap on your body. So why should you mind having rainwater on your body? Have it and then maybe use it to rub. Let's say you are in the camping. You are camping like Fandi just now and you have no water. There's no shower facility. You have to shower in the rain. If next time, no. During war, you think there's a shower room there? No. So will you shower in the rainwater? You given the choice? Given no choice? Yes. Okay. So rainwater can be clean as well. Okay. So you have to use it to wash corridors, wash cars if possible. Okay. Try and do that. You do conserve water. So the finally, only A is left. Then you use a hose, because a hose is similar to the tap. A hose, because you open the tap, you fix a hose, and you let the water run. Same thing, right? So anything that you let the water run, you are wasting water. Instead, what should you do? You bring a pail. Just like during the brushing your teeth, you use a mug. So when you are watering the plants, you bring a pail, fill up the pail, and you can control the amount of water that you are pouring onto the water instead of letting the water run. I'm sure you can realize that when the water is running, you always cannot control. Then you must run back to the tap, off it, come back. By the time you run back, you already waste all the water. So this is not a way to conserve water by using a hose. So answer is A. Okay. Let's go enjoy the rain and shower in the rain. I have a balcony. I can just go stand in my balcony and just okay. You guys want to see? I like to share with you. You guys want to see? Okay. So this is my balcony, and I can just go out and just have some rain. You guys can see. Okay, that's just some fun here. So I'm very near the rain already, the balcony, so I'm going to have some fun. You can go and play with water because it's very rare that we have rain. Okay. Okay. I'm going to end the lesson. The only thing left is go and download the lesson notes, which will have all the answers. Because when you download, I will include the next week's quiz there. Many of you say, "Oh, I forgot to see the quiz." I didn't show the quiz. The quiz was in last week's lesson, the last slide. You may have missed it because you actually logged out or you went away. So I will also put it, and I did put it in last week's notes. This week's notes will come out probably tomorrow night to have all the answers and the quiz. I will write down where you have to send your answers. Send me the answers. We'll pick a winner next week, definitely. Because this week, because the questions were something that were not taught yet. Of course, I expected you to know from your school, but the answers were not good enough. You need to be better because at PSLE level, the answers have to be great. Otherwise, your grade will not be A, it will be B, it will be C. So we are trying to get you into the A grade. Then you have to take part in the quiz. Is that a deal? So next week, I'll see more participation. And the participation is all by WhatsApping me onto my phone so I can get it immediately. It's not an email. Email will take too long. I won't check email, but phone is very fast. Anybody who take part, I will see it in my phone. Okay? Take care. See you next week.